This is section 2.5 of college algebra, absolute value equations and inequalities. And first of all, let's talk about what the absolute value looks like. And if x is negative 2, absolute value of x is 2. If negative 1, it'll be 1, 0, 0. And if it's 1, it'll also be a positive 1. And if it's 2, it'll be 2. So what you should understand is that absolute value can be equal to 0 or can be positive, but it will never be negative. All right? So this is what it basically looks like. And it's increasing when x is greater than 0. It's decreasing when x is less than 0. Let me see if I can get where we can move here. All right. I need my little deal. All right, so when you're solving these graphically, because that's what we're going to do, we're going to be using our calculator to solve these. When you solve them graphically, you could have two solutions if you have two places where it crosses the x. You could have one solution where it goes down and touches the x and goes back up, or you could have no solutions when you're up in the air and it doesn't intersect the red line. Okay, so you'll see that when we start working these problems. So either two solutions, one solution, or none. Okay. All right, so here's an example, and we're going to use our calculator, and we're going to go to our calculator and clear that out. And to find the absolute value, you could do it two ways. You can go to math, over to number, and it's the very first one. So that's one way. Now, in newer operating systems, you actually get the absolute value lines. If you have an older operating system, it'll just say ABS and it'll have a parentheses. So inside here, I'm going to put 1 minus 2x. And then I'm going to use my right arrow to go out of those bars. And I'm actually putting in this because I had to have everything on one side. So I'm going to have a plus 3. And I'm going to put y2 to be 0. All right, now here's what the original problem looked like, and I moved that 3 over and had 0 on the right. So remember that we put our left side up here and our right side here. So I'm going to hit graph. All right, and that's what I've shown you here. Now, remember, if you don't touch the x-axis, you have no solutions because those would be imaginary solutions. So that's the kind of picture that we're looking at, and we'll do it. So I would suggest that you go to your calculator, you put it in, you get a sketch, and that will help you do that. So let's look at this one. Same way, I put y1, my absolute value, minus 15 and 0 here. I got this picture. You might have to change your window a little bit to be able to see those. So just adjust, but you want to look for these x values here. So if you do second calc intersect, you're intersecting this line, which is y equals 0, and your curve, which is the absolute value. So you do it once, you get negative 12. You do it a second time, you get a positive 28. And those are your solutions. Okay? Negative 12, comma 28. And you would write them negative 12, comma 28. Those would be your solutions. Now, for inequalities, you're going to have a whole region. You're going to have an interval that works. Okay? So, there is some little pictures here, but I think actually you're going to see it better when we do it on our calculator. So let's let's go here. All right. This inequality sign gives you a lot of information. If it has the equals under it, then when you do your sketch, you're going to use closed circles. It tells you you will use brackets in your answer, and that your solution is below the x-axis. Okay? So in your calculator, you've moved the 6 over. So you have the absolute value of 2x minus 5 minus 6 and y2 to be 0. So we put that in and we get this picture. We do our sketch and we put in closed circles and we highlight below the x-axis because that was less than. If it had been greater than, we'd have this highlighted and this highlighted. All right. When you find the intersection, you get negative 0.5 and positive 5.5. The solution is the blue part. We include these numbers, so they'll be in brackets. So it's from this point, follow the graph, to this point. So you could write that answer two different ways. In interval notation, or negative 0.5 less than or equal to x less than or equal to 5.5. We'll do both in the problem set. Let's look at the problems. All right, first question. The function 2x minus 10 is given. Graph regular f of x and absolute value of f of x, and then find the x-intercept. Well, you actually could determine, given these three, it's not this one because it's a straight line and that's absolute value. This is a negative slope line. That's gone. So this would be our solution. F of x, the absolute value of f of x, we can mark that one out. This is a positive thing, so it is right side up. This is upside down. We can mark that one out. You can put it in your calculator and find the x-intercept, or you could count and see that that is equal to 5. Okay? Let's look at number 2. All right, number 2, when we put it in the way we said, here's y1 and y2 would be equal to 0. You get this picture. There are no x-intercepts, and so it's no solution. This is another way to get absolute value. Second 0, which gives you the catalog, and the first item under catalog is ABS. So either that or the math and over to number, and it's the first one. Okay? All right, let's look at number 2. All right, we subtracted this whole absolute value, and then we have y2 to be 0. Here's what my graph looks like, what you should get when you try that. The solutions, what do we have? We have one here, one here. It's 0.7 and 1.375. And I believe, I don't know if it's wanting fractions or not. On your calculator, if you get a decimal value, get this out of here. So if you have 0.7 in your calculator and you want to have that be fraction, choose math, and the first option's fraction, and it would make it 7 over 10. So if it requires a fraction, you could do that on your calculator. Whoops, I went too far. Okay, number 4. Same thing. Y1 is this. Y2 is 0. You have a negative 3 and a positive 3. And that's that. So that should be coming a little bit easy. Now this one is one solution because it's that V that's just touching right here and not going through. So the answer would be negative 1. You would have one solution. All right. This one, now you got to think about this. If you graph it, you're going to see this picture and it would be no solution. But, and if you can't see it, you can always do zoom 0 to get the view. But what I want you to think about is you've got an absolute value equaling a negative number. That can't be. Your absolute value is never going to be a negative number. So that's another way that you know it's no solution. All right, 7. It does want fractions, I believe, and you would get 0.75 and negative 3.5, I think, if my graph is right. So 3/4 and negative 7/2 would be your fractions. All right, let's look at some inequalities. All right, remember this is what we look for information. We're going to have closed circles below the x-axis, means we're going to use brackets. So you put this in y1, this in y2, and you just get probably these lines here. I filled it in. You're just going to get that, but you don't care about down here, so that's okay. Find this x-intercept in this one. You get -9 and 8, and you do know that you're talking below, so that it does that somewhere, and you go from -9 to +8 with brackets. Number 9, now we're above the x-axis. We have open circles in our sketch, and we have parentheses in our answer. All right. All right, so on this one, when you do this on the calculator, you get this number for this one on the left, and you get 1 here. But this is asking for fractions, and that's one of the numbers that will not convert on your calculator for a fraction. So if you end up with one of those where it doesn't convert, then this is what you want to do. You have to do that symbolically. You take what's inside here, take the 5 minus 7x. It's either going to be greater than 2 or less than -2. You do the positive and the negative. Solve each of those, remembering that when you divide by -7 here, the inequality flips. So you have x is less than 3/7 or x is greater than 1. And it says do it in interval notation, so that would be from -infinity to 3/7 or 1 to infinity, which would have been, we still would have got that. We would have had -infinity up to whatever that was, which is 3/7, and from 1 to infinity. But I suspect many of you, when you get your problem generated, would have one that doesn't convert on our calculator. All right, on this one, here's your graph. It's greater than, so we have open circles, meaning we'll have parentheses, and it's the two pieces above. So when you find those two, it's -4 and +52. Probably have to change a window to see over here. And so we've got -infinity over here and +infinity here. So we go from -infinity to -4, that's this piece, and from 52 to infinity, and we get that piece. So that should help you get through section 2.5.